So recently I explored the Grafana platform for monitoring and I've created a user guide based on that. The user guide is available on my GitHub repository. So what I did was while I was exploring the platform, I took all the relevant screenshots and later on I created a user guide based on that. So let me quickly run you through what all is that you can do in Grafana and how to visualize or how to interpret all of the metrics that you get while you're doing observability on GPU and server systems. So first of all, when you open Grafana, the homepage looks something like this. So as I told you, I have many screenshots. I'll be going through all of them to show you how the interface looks like. So yeah, this is the home page. Here we can see the recently viewed dashboards. So this is our dashboard. We are going to take a deeper look on what it has. Then if you take a look at the navigation sidebar, here we have the dashboards. I'm only going to focus on the relevant items here, not every items. One is the dashboard, then is the alerts. Alerts basically, let's say you have created an alert. If the GPU utilization is more than 95% for 5 minutes, you will automatically get an alert. So all of that comes under the alerting menu. Alert rules are the specific rules that you have created, like I just said. Contact points are basically where do you want to receive your communications of the alerts, and notification policies is that how frequently do you want your alerts to be notified, let's say to your phone number or to your email ID, right? So first we'll explore the dashboard item menu here. So here let's open how the dashboard looks. So here we are going to look at this dashboard, GPU plus host. So yeah, so first and foremost, to get information about NVIDIA GPUs, you need to use a DCGM exporter. So DCGM exporter has very fine-grained granular details on how the GPU is performing and all the relevant metrics. And to get real-time data out of it, you use Prometheus. So you have DCGM exporter, then you have Prometheus, and all of that data goes to Grafana, which is, to simplify it, it's a visualization platform. So here we have data about our GPU utilization. So as you can see, the GPU utilization is at 0%, encoder, decoder utilization, everything at 0%, which indicates that our GPU is idle. And here, but you can see the frame buffer used, which basically means that how much the memory is being used. Here we see it's very close to 150 GB. So the amount of VRAM in H200 GPUs that we are using is 141 GB. So essentially the entire VRAM has been occupied. So what this basically indicates is that we have an LLM or a model loaded in our memory, and we aren't really requesting any data from it. We aren't the model isn't serving anything. There is no inference happening on that model. It has just been loaded into the VRAM. So the GPU is essentially sitting idle. So if we take a look at the clock speed and GPU thermals, here we can see that it does fluctuate quite a bit, which indicates that there have been short bursty traffic. And here, as you can see, the power usage fluctuates between 0 to 75. Now 75 is very low for an H200 GPU because it can pull a maximum of 600 watts, which basically tells that even though there were a lot of short bursty loads, the workloads that were executed weren't that intense to begin with, right? Now we take a look at what happens in the PCIe and NVLink. So I'm going to elaborate on that as well. So then we move on to what's happening in the PCI link. So PCI TX basically means PCI transfer. So PCI bus is a data bus which is responsible for transferring data between the CPU and the GPU. So PCI transfer basically means the data which is being transferred from the GPU to the CPU, right? So as you can see, there's not a lot of data being transferred. As you can see, the maximum is 625 kbps, which means that the GPU is essentially idle. And when you take a look at PCI receive basically means that what data are you getting from your CPU to the GPU. Here is the same case. We are not getting a lot of data. The size of the data is varying from 0 to 27 KB per second. So that's not a lot. The GPU is idle. Then we take so all of these were GPU metrics. So GPU is just a part in a server, right? You also have memory, the RAM of the server, the NAND storage, the NVMe storage that the server has. Then you also have the CPU cores that the server has. So we were taking a look at the GPU. Now we are taking a look at the entire server. So to get the data from the GPU, we use DCGM exporter. In the same way, if you want to get the data from the actual host machine which has the GPU in it, we use node exporter. Let me give you an example. I'm going to take the example of my own computer. If I go to the performance tab here, my computer has many components. Think of my computer as a server. My server has many components. Just one of the components is GPU. As you can see, I have some data of my GPU, how it's being used. Video encode is 71%, 8 GB of 8 GB of memory is present and 1.4 GB is being used. So the GPU data comes from DCGM exporter, while the data about the CPU, the disk that I have, the memory, the amount of RAM that I have, all of this comes from node exporter. Hope this example makes it clearer. So let's take a look at the data that the node exporter has given us. So here we see the stacked CPU utilization. The reason it shows 2400% because it has combined the usage between all the cores. So and in enterprise grade HPC deployments, the AMD EPYC or Intel Xenon chips that are used, they typically have like 64 to 128 cores. So that's why the percentage is so high. And here, as we can see, the memory that we have is the total memory is 126, and only approximately like 6 GB, 6 gigabytes out of these are being used. So the system is idle again. Then we have completed looking at our dashboard. The next pane that I told you that is important is the alerting menu. So this is how the alerting menu looks like. So it is basically just documentation on how it works and how you can use it to set your own alerts. So let's dig a bit deeper. We can go to the alert rules page. When you go to the alert rules page, you get to see the rules that you have created. The rules could be, if your GPU's utilization is less than 5% for like 10 minutes, you will get a notification. Now, why would you want such a notification? It basically tells you that the GPU that you are using is the GPU that is being deployed is underutilized. So you want to know such information because then you can look into it, like why is the GPU not being utilized. So this is just one of the many alerts that you can create. So now let's take a deeper look at this specific alert that we have created and what it basically monitors. So this is a Prometheus rule in particular, and here as you can see, it looks for any hardware errors in the GPU every 5 minutes. So if the Prometheus rule finds any errors in the GPU, then it automatically raises an alert. Now there is nothing to be alarmed about right now because as we can see the state is normal and we have no new alerts. So this is just one of the three rules that we have created. Now that we know how alert rules work, now we can go to the contact points. So as I previously told you, contact points is basically just where do you want to receive your communication regarding alerts. So here we have just gone with the default options, which is example@email.com. You can replace it with your own email, and as you can see there are no delivery attempts because there haven't been any alerts generated in the first place. Right? Then we go to the notification policies. Notification policies basically state that how frequently do you want to receive the communication regarding your alerts. So we haven't set any explicit policy. So we are using the default policy in this scenario. So the default notification policy in Grafana states that whenever an alert is raised, it doesn't directly send you an email. It waits for 30 seconds to see if any similar alerts have been raised so that they can be grouped together and then sent to you. And after the first alert has been sent, it waits for 5 minutes to send you another update. Because the thing is, let's say the alert is for if the GPU utilization exceeds 85%. Now you have received an alert that your GPU has exceeded 85% utilization, and it's a continuous alert. So if the Grafana doesn't wait, your inbox will be continuously flooded with GPU usage exceeded 85%, 85%, 85%. You will get multiple such emails. So why are we waiting 5 minutes? Is basically that now that the user knows that the usage has exceeded 85%, there is the if we send him the, if we send them the information again and again, it's very redundant. So if we wait for 5 minutes, the alert may cool down, and then we can send any new alerts if possible. Then if you go to mute timings, this basically controls how you can silent the notification or mute the notifications. So as we haven't received any notification yet, so we also haven't created any notification, any rules to mute or suppress the said notifications. So this is essentially what I did using the Grafana dashboard. I will be exploring more such technologies in the future regarding HPC, AI infrastructure, cloud computing, and I'll be documenting most of it.